They given like SDC file and UPF file. So we'll see what is SDC file. So I'll open SDC in the designs SDC file. So if you observe SDC file, so here it's like basic commands. Create clock, set clock uncertainty, clock latency, clock transition, and some IO delay constraints and load constraints. It is basically, generally we are going to provide you in your script file. But here what we are doing, we are just giving some other, we are creating a SDC file. That means we are creating another type of file and we are writing whatever the scripts in saving in a SDC format, because this is the format for SDC file also. .sdc means synopsis design constant file. So this .sdc file syntax is the same as your script syntax. So that's why these constraints we are writing and we are storing in .sdc file and we are considering as an input. Or else you can take it out and you can give parallelly along with your tool also, because this is one way of providing the inputs. Because some of you ask like maybe if they give you only RTL and some SDC, so you may think that sorry, we are going to write out the SDC, how we can give the input as a SDC, because input also, because these are the constraints, design constraints, you can give input also, but after applying to the design, how you are going to write out, that is what you are doing. So initially it is like these are input constraints. After finishing synthesis, you are going to get another SDC, that is like writing out your design constraints after applying to your design. Okay, so I don't take much time on this thing. And the third one is like this is the major one, UPF. So can anyone tell me what is UPF meaning? UPF, what is UPF?
A unified power format.
Very good. I hope Jayendra knows.
Abhishek here.
Abhishek, yeah, good Abhishek. Okay. So UPF means unified power format. So here, this is also considering as a UPF. So from where you will get this file means from the low power team. So there is a power team is separately is available in your companies. So those people will provide you this file, UPF file. So for the same design, whatever the design you have, they will write some constraints, and those constraints they will consider in a UPF format and will be giving you as a input to your synthesis tool. So based on those inputs, you are performing your logic synthesis based on your UPF files. So what it is basically, it is contained means it's just having the power information. Like there are different power multi voltages are there, and there are DVMF, dual voltage multi-frequency, different scenarios are there. So all those scenarios, these low power team will write a UPF file and will provide it to you. So we'll see what is this UPF file and how we are going to create. So before going to that, I'll just tell you on what basis they written this file. So for your countertop. So here I'll just take a paint because it's easy to explain. Yeah. So this is your counter.tp. Okay. So sorry. Yes. So this is your counter underscore top. So this is your counter underscore top. So for this you are going to create some power constraint. So if you see, there are two modules are instantiated. One is proc 0 and another one is mcore 0. I'm just drawing. So this is one of the proc 0 and there is another one is mcore 0. You can just give some name. Proc 0, mcore 0. So this is what my design actually, countertop, proc 0, mcore 0. Now I'm going to constrain the file. So what is the design constraints? What is the UPF here they written is like counter underscore top is one voltage it is going to operate, and there is a proc 0. So this proc 0 will operate at other voltage, that is at 0.85 voltages. So this block should operate at 0.85 voltage, and your mcore 0 is operating at 1.05 voltages, and your counter top also should operate at 1.05 voltage. So these are the multi-voltage scenario. So there is, for example, if you consider this is your top block, so in that one module is working at 0.85, another module is working at 1.05. So now you need to create a UPF file for this thing. So how you are going to do generally, like don't go for the file format. File format I will explain you. Generally how we can do. So first we can create one port here. So what you'll do, you'll just create some port. What type of port you are going to create? So you just mention VDD P. So this is one port. So VDD-P is basically like how much you can mention. So you can give as a 0.85. So this is VDD net, VDD port you are creating. From VDD-P, it will be going 0.85 is coming from this port only. Okay. And another one is like VDD-M, main supply. So main supply of 1.05. So these are the top level ports you are creating. Okay. So these top ports are available in your countertop. I mean, this 0.85 net is available, port is available in your top level, and 1.05 net and ports are available in top level. From here, you are just passing through some nets to your proc 0 and mcore 0. And there will be third one also there. This is your VSS. So VSS basically it's like a 0. So no issue with that one. Okay. So now we are going to start. This is one net. This is another net. Okay. So this is VDD-P net and VDD-M net. Now you are going to send to your design. But here what is there? From 0.85 it is coming to your proc 0. But before coming to proc 0, here we are providing another constraint as a switch. Okay. There is a power switch is there. So what is this power switch basically will do? It will take your 1.05. It will take your 1.0. Sorry, not 1.05. It will take from your 0.85, and based on some control signal, it will enable. Like this is like basically on-off switch. On-off switch. Okay. So there is a controller is available to you. So through this controller, this 0.85, this VDD-P will coming to this block. So here this is actually your supply. So this is we call it as a you can mention like VDD-P underscore gated. Okay, of 0.85. Basically, this is the net. Yeah, now it's clear. So basically VDD-P is your main supply is available in your top, but you know like there is a separate module you are created, and this is working at 0.85 only compared with your top module. So that's why there is a power controller switch is there. So basically this switch will control based on some other signal, control signal. So once the control signal is enabled, then this switch is on, then whatever VDD-P will come into your block, your particular proc 0. Okay, so what is the power supply for this block? VDD-P gated. It's not VDD-P, it is VDD-P gated switching. So this is power supply net. From this VDD-P underscore gated, it will go to each and every standard cell sitting in this block. That is how the power switch is working. So on what basis this will be going on means there will be some controls, like there will be control signal will be there. So that we are going to provide you. So we'll tell you how you are going to provide the control signal. So that means this is perfect. So this means there is a switch is there and it's working fine. Now we are going for another thing. Like here, there is some connections are between these two. So maybe like there are few connections between proc to M core, correct? But both are operating at different voltages. This is operating at 0.85, this is operating at 1.05. Now what you are going to do, and another thing is here there is another switch, on-off switch is there. So this is basically on-off switch. On-off is performing based on your control signal. So if it is in off domain, then what will happen? Whatever output signals are available here, everything will be having some random value, some dump value. So whatever the connections to the other block, so those dump values will be processed. So what you need to do, you need to provide some constraint or something so that when this block is off also, the communication should not disturb. So it should not change any functionality. So for that one, you are going to use some isolation cells here. So here there is some isolation cells you are going to use. So this is basically isolation cells. So some isolation cells you are going to use. What this isolation cell is doing, isolation cell basically it will clamp your output value. So it will present in the output side, or else you can place here also, no issue. You can place here, or else you can place here also, there is no issue with that. But while placing, you need to provide which location you are going to place, that we'll see in the command. So what it will do basically, it will take all the outputs from the proc 0 block and it will clamp to some value, basically clamp to 0 or clamp to 1. So clamp to 0 means your output will be always 0, always 1, so that this 0 will be propagated to your M core 0. So this is what is the use of isolation cells here. Okay, and another thing is here, whatever the signals are coming, those signals are going from 0.85 to 1.05. Even in this domain also, this is also 1.05 domain. See, only in this boundary it is working under 0.85, and apart from this boundary everything is 1.05 only. So you need some level shifters. To come into this block. Here also you need some level shifter. So for inputs, you need which type of level shifter you need? From 0.85 to 1.05. Level up. From here 1.05 to, again if any signal is going to this block, then you need level down. So these are the two types of level shifters you are going to use. Okay, so here in our agenda you are going to create different ports and different nets accordingly, and after that you are going to create power switches, and you are going to define some domains. So this is one power domain, this is another domain, and in the one domain you are going to mention a switch, and you are going to create isolation cell to clamp to some value so that your output will not be disturbed. And after that you are going to use some level shifters from other voltage to the particular voltage. Level shifters up or down based on the location you are going to use. For the inputs you are going to basically use up shifter, and outputs it will be down shifters. So these are all the cells, power switch, isolation cell, level shifter, these are all available in our library. So you need to provide additional library here. Apart from your logic library, there is a power PZ library will be there. From there you are going to consider these signals, these cells, and you are going to target while doing the synthesis. So once the synthesis is over, then these cells will be inserted, and you can see the power domains also. So this is M core power domain and P core power domain, how it is created we can see in the synthesis, after synthesis also. So that is what we are going to do. So this is basically our specification. Accordingly we are writing, somebody written the UPF file, and we'll see how they written, and after going to the lab I'll tell you how you can write your own way of UPF also. Okay.